Well, at the beginning of this event, we have tried to explain the bigger picture and to put into context why we are doing this at all and what new opportunities it gives us. We have now seen several results which have been achieved through the workshops. Of course, nothing fell from the sky. Of course, know-how was involved, which we have accumulated over the past years. Of course, we use analysis toolkits that we have developed and programmed over the last few years. But we now put all together in a different way and can thereby speed up data evaluation. Here and there we have already addressed the key point. We do not only measure structure-borne sound, but we can now also measure other properties. Our micromagnetic team primarily works on the basis of magnetic fields, the measurement of magnetic fields. We have gained experience through a project that Sören did with Scheffler and used this experience. Yes, Barkhausen noise, micromagnetic analysis. However, we have quickly started to design and manufacture our own sensors, and we continuously develop own sensors to further improve in the area of air gap measurement, our field of expertise. In fact, we do not only measure magnetic fields, but also use laser distance for such measurements. So we already use data from two different information inputs. And we also retrieve coordinate data from the robots and use it as well. And we have also discussed in the context of other application cases that we could measure temperature, pressure or force displacement as well. In the case of welding, we now also measure current. So we can integrate and use additional information from the machines very well.
I think a nice example is the result of the Pronovis project. Let us watch the video to get an impression. Many thanks to Olaf, he has produced a lot of aluminium chips together with marks from very massive blocks. This is also a wonderful example for the project teams who come together to realize a solution very quickly. And what you see here is called QASS Cube. It's a direct pre-project result. In fact, we have coupled our optimizer, our acoustics, with other sensors. Namely, an electrostatic sensor from the University of Southampton, an infrared spectrometer, and carry out tests on systems that simulate wind turbines and so on test benches. We were then asked by the project partner, please put that into a product. We developed this product in a very short time and transfer it into an analysis capability. And we developed this idea further as we typically do at QASS. The result was that we developed a measuring capability too. In other words, bearing fail too fast and too early, although they should not actually do so. This loop life project. We actually changed our approach to measurement technology even more in the future. Thus, we obviously use all the possibilities that are now available in the software. We also want to think a little further. Approach the topic Sensorfusion together with a few partners. ASC is one of them, Hudak is another one, and so on is Compass. And we will tackle oil analysis. Hudak will supply us with high quality oil sensors whose signal data will be processed with our measuring technology. Compass will provide a so-called miniature tribometer, with which we can evaluate the contacting between the lubricant and the bearing. Everything will be integrated into a system which ASC will provide us with. And this system from ASC uses a unique approach. It allows us to make predictions for a system. So once we will have accomplished an oil evaluation, a condition assessment will be able to determine which factors in the lubricant should not. An example would be the water intrusion. When water intrusion becomes too high in a lubricant, it can lead to siltation, in turn results in filter blockage. Then the machine completely fails. And then we have a non-rotating wind turbine. And we do not want that, of course, and obviously we want to contribute so that wind turbines run for a long time.
Sören, who will decide whether the machine should be stopped or not?
We will not actually do that. In this case it will be the operator, but we will provide the decision support.
The operator is the QASS operator in our operator network?
No, the operator is indeed the user who will receive our sensor signal. Because in this case the clue actually will be that we will process the data which we will receive from the wind systems on central servers here at QASS. The predictive algorithms will not longer necessarily run on the optimizer, but here in our network center.
Once again, Sören, who will be responsible for the decision? Who will provide the operator with the decision basis?
The decision basis will be provided by QASS.
We will do that. So will not be ASC who will do that?
No, we will do it.
What will ASC deliver to us?
The prediction models. So that we will apply oil analysis and evaluate sensor data accordingly.
Which means they know how to do it. Okay, and who will program it then?
You.
Okay, or I will find a team for it. And we could probably program it in Python, right?
We could program it in Python, right.
Okay, so the idea behind it is that we concentrate on new questions, atomic models, chemical models, which are ultimately responsible for the maintenance condition of wind turbines. So it will be a good contribution to energy change if we manage to do this well.
With a high impact, a high responsibility for our environment? Sure.
Yes. Okay, and it will be also us who will put the pieces together in this project, which means sensor integration. With virtual inputs or through other processes, we can read in different information and then channel it via data streams to our analysis tools. And we could then copy the algorithms from ASC, but I think that we will have to add further aspects and work on the algorithms, not only to realize an automatically functioning system for this project, but ultimately also to make it ready for operation on wind turbines. This will be a good example for other funded projects that we work on as well, right?
This is how we understand QASS.
Yes, okay, thank you very much. So this was a somewhat longer run with smaller obstacles in between. It was an attempt to inform a more or less compact way about what we have done new and what we will do new. And a key aspect is the new mode of operation and approach. The team structures will certainly not remain as they are now, because we have already seen in the workshops that we can work very effectively on such topics within new team structures. We choose a subject and then 2 or 3 colleagues work together on an algorithm or an implementation. And in this way we can deliver a meaningful product that we can market and sell. And sales are necessary because in the last 3 months sales were quite low. We are also affected by the shutdown, the lockdown of the automotive industry, of the entire industry. For all supply industries worldwide it is the same situation. It is the 3rd month in a row that we are in such a situation. On the one hand, I think that we have used the time very well to get prepared to develop something new. But on the other hand, of course, we now have to get these achievements out there. In other words, when we get inquiries and have the opportunity, then we have to say, okay, we will do it, we will deliver it, we will implement it, and we will get it out. Certainly, this still requires a lot of training. For many, scripting means that you suddenly have to deal with programming, even when you had no intentions to do so at the beginning of your professional life. So maybe you had a different idea, but now it is required. Both process expertise and algorithm implementation. And in the end, you will be happy when you finish a product that someone can use, for which someone is willing to pay. Yes, so thank you very much.